Hello, everyone, and welcome to the Ethereum Core Dev Meeting, episode 99, Spooky Halloween Eve edition. Today we're going to have a ton of fun and games, including some stuff that is Halloween themed. Just kidding, that doesn't happen in the protocol development world. Okay, so the first thing we have is the YOLO v3 in Berlin discussion. Let's go through the YOLO v2 and v3 spec update from the client teams that are here, and I'll have James run that part, and then we'll go over some of the stuff we talked about asynchronously in Discord over the last week, with the main discussion questions I'd put in there, I think, on Tuesday or Wednesday. So James, take it away.
Yep. So looking at the YOLO v3 spec sheet on Ethereum 1.0 specs, I'll put it in the chat here for people to look at. I'm going to just go through and ask each client the status on whether they've merged or are they syncing or their plans to. Starting with Besu.
So is this for YOLO v2 or YOLO v3 that we're concerned mostly about?
Oh, it should be YOLO v2, right?
Okay, yeah. So we're on YOLO v2 right now. We have the 2537 under the original pricing scheme. We have the subroutines under the updated rules, and we have the access lists. And those outside of the currently YOLO v2, we've independently run it against Geth on the existing reference tests. Now, I still think there's some holes in the reference tests. I think we need specific reference tests targeting the rejection of the lists on reverted transactions. But other than that, it looks like we're aligned with what 2929 requires for YOLO v2. We haven't done either of the two YOLO v3 ones yet. Those probably take about a week or two. That's the wrapped transactions and the 2718. Is that the repricing? Or the type transaction envelopes and the access envelopes. We haven't done any work on that yet.
Okay. Great, thank you. Geth?
Yes, so we are also done with YOLO v2. And I can also give an update that the tests, the consensus tests have now been regenerated with the new Berlin named tests, which contains YOLO v2. And just today I updated Hive to actually start using them. So yeah, within the next couple of days, we should start seeing failures for the clients that have not made it activatable. As for YOLO v3, there is an open PR for 2718 and 2929, which we need to review and see if it's mergeable. What else? Is 2565 on the table as well? I think we have merged basically 2565, but it's not activatable right now.
And so would that be like a week or two of work? Same with how Besu to get done, say?
And hard to say really, because the transaction changes are pretty large. So it might, I mean, we're pretty slow at merging large PRs. So I can't really, I can't say right now.
Okay. Great, thank you for the Nethermind.
I pinged Thomas to come in to the meeting if he's up and around.
Then we'll get back to him if he gets here.
Just got here.
Oh. Perfect timing, Tomas.
Sorry, guys. The time zone changed and calendar was still showing the old time. And then I noticed the Twitter entry from Team. So Team, great that you post live.
Glad that it helped.
If you're asking about Nethermind progress. So We've seen today some failure on the Bezu Nethermind EAP 1559 integration. As for the Berlin Yellow V2, will join as soon as Bezu and Get has running version. I think that Martin was mentioning this week that it's already done for 29.29, so we should join soon. Apart from that, everything else is nice. We're still looking for what's being added. I mean, I've seen 2666 is on the agenda potentially, 2935. Myself, I was working on it and it's ready. So have a look at the recording from Pooja about 2935, what we think about it and how it can improve Ethereum. Yeah, that's it from us. We'll join whatever is there. I mean, like I'm not trying to say no to any IP that is decided by others. We'll join and we'll do whatever is decided for YOLO V3 or V2.
Great, thank you. And then Open Ethereum is not participating on YOLOs at the moment for the last piece.
Yes, that's right.
Cool.
Sorry, one more thing from me. So we are now trying to build and connect the GMP library to support this ModX repricing. So you can also go with it if it's all ready, and we'll add some library that will probably provide proper performance if needed. So no problem with that as well.
Okay. Thanks, everybody. I think that's it for the client teams that are participating in YOLO, right, James?
Yeah. So then for Nethermind, that means you're mostly merged but not synced, not syncing to the network yet. And Besu and Geth are both syncing for YOLO V2.
Yeah. By the way, I could also add. So for YOLO V2, there has been zero activity. But what we plan to do is take everything that was, all the transactions from YOLO V1 and replay them on YOLO V2, which should, I think all the fussing stuff that Marius did was done not using replay protection, so we could just lift it across.
Wow. That's pretty cool.
Yeah.
Awesome. Okay. And for those tuning in or on the call that want to know what's going into these YOLO specifications, there's a repository on github.com/ethereum/eth 1.0-specs specs. And I think that's in chat right now, actually. Yeah. So James posted those links in chat. So feel free to check those out to see exactly what commit hash to use for which EIP's specification when implementing. Okay, if that part's done, I'm going to copy and paste into the chat some of the stuff from Discord. Here. So, I had 3 questions that I posed during this week on the 27th. When was that? Was that like a Tuesday? Yeah. That we need to figure out relatively soon in order to go forward with Berlin, so we're not dragging that out any longer. So, the first question was, do we all agree that all of the EIPs that successfully passed YOLO V3 plus EIP 2565, the mod EXP gas cost EIP, can go into Berlin? So that's all EIPs listed in YOLO V3 plus EIP 2565 going into Berlin. And I didn't see any dissent. I think Nethermind basically said they're good to go for that. The one exception will be something that I listed in question 3, which was how comfortable people are with moving forward with 2537. And so, but before that, the other one is, are client teams comfortable with implementing the list from YOLO V3 in 2 to 4 weeks of dev time? What do we think on that second question? Do people think 4 weeks is enough time to implement everything from YOLO V3 for those who are doing YOLO?
One quick question.
Mhm.
If we're going to do 2565, why don't we just pull that into YOLO V3? Is there a reason why we shouldn't? The mod EXP gas repricing.
The reason that was given last time was just it's so small we don't necessarily need to put it in. But I guess you could literally flip that and say it's so small, why don't we put it in?
Yeah, it's going to be easier for me to code it with it as YOLO V3 than it is to code it without.
Yeah, good call. James, can we just change Yellow V3 to add that to there?
Yeah, we can do that.
Okay. So yeah, we'll have James go in and change that, and that will be what people we can just say Yellow V3 at that point and not have to include other EIPs. So other questions on that?
Yes, just to clarify, so 2537 and 2315 are linked with a certain commit hash in the specification. Is that the exact same one as was used in YOLO V1 and 2, or has there been any changes at all?
They're the same as far as
it should be the same.
Thanks.
The reason why specific hash is linked is because I will have another PR.
Yeah, it's good that it does link a specific hash. I just wanted to clarify that there were no changes.
It's also to not make a mistake, because last time we had some play with a bot who merged the PR which was in the draft. So it will be a little adjustments of gas prices, constants only, no changes in other parts of the spec. And this I don't publish yet, just to avoid any confusion. So whenever maybe James indicates that it's fine to publish kind of a final spec for Berlin, I will just merge it.
Wow. I'm not really comfortable with that, actually.
What do you mean, for changes of the gas prices, or what?
Yes.
Well, actually, a gas implementation is faster than the 1962, which was used to derive previous prices and new prices. So you have a very good margin.
Yeah, I guess we'll have that discussion later on when these changes are made.
It would be nice to get those things at least together earlier, so then clients and stuff can be ready for it. So,
well, I can publish a draft or even merge it. It's up to everyone. If you just want to consider as a spec final, or just look at the draft.
Well, I mean, once you update the gas, we need to redo some benchmarking, and people need to give thumbs up or thumbs down if it's okay on their notes.
Well, okay, I will just merge it after the call. In this case,
let's merge it after the call, and by the end of today, let's get a new commit hash on there for those that Alex is merging, at least.
Yeah, and we'll put that in for YOLO V3, and then with that in mind, does that change your answer? Any answers for 2 to 3 weeks for YOLO V3?
Or 2 to 4 weeks, you mean?
Yeah, 2 to 4 weeks.
Yeah, I'm just do those changes on master, do they also change how errors are handled or not handled?
No, it was removed. So there are no changes from like logical and mathematical parts. There are only changes in numeric values of the constants.
Okay.
Okay, so yeah, y'all don't have to have an answer for this, since we don't have, we're not implementing V3. Some of us aren't implementing V3 completely yet, but I guess I can just go through the teams for a 2 to 4 week time window. What does that look like, Besu, for finishing Yellow V3?
The gas repricings are easy. It seems like a reasonable time frame for the transaction envelopes. That being said, we won't support YOLO V2 and YOLO V3 at the same time. It's going to be pick one based on commit hash. So.
Yep. Okay. And this would be not having Yellow V3 like done to or not having Yellow V3 launched, completed, and killed in 4 weeks. This would be having it coded up to start going with Yellow V3 with between 2 and 4 weeks. That was the question. I think I should have been more clear.
Launch it in 2 to 4 weeks. Yeah.
Yeah. Okay. Geth, what about y'all?
Possibly.
Okay.
Yeah.
That's fine. We don't have to have a complete answer today. We'll have more info on how it's going in the next meeting. And then Nethermind, I think you already answered you're on your way. So this sounds like a good timeline.
Yeah, I mean, 29 and the remaining things are mostly ready. The envelopes seem to be fine to do quickly as well. 2930 goes in as well, right?
2930 does go into Yellow V3, yes.
Yeah, should be fine.
Okay. And then Open Ethereum's not participating in. Oh wait, is Open Ethereum not participating in any of the yellows or just Yellow V2?
I think we are just Yellow V2. For Yellow V3, we should be prepared. But I need still to check that because we already started 2930 and 2929 is close to finish. Basically, it passes test. We should be in that timeline for 3 weeks, be ready for Yellow V3.
Okay.
But yeah, we need to check that, but probably will be okay with the timeline.
Okay. Sounds good. And you can give us an update next meeting if something changes in that estimation.
Okay, deal.
Okay. I think that's all the teams. So it sounds like we've answered question 2. So question 1, it sounds like we have Yellow V3 shaping up to include EIP 2565 and to include new commit hashes for some of the EIPs that are getting merged today. And then question 3, are all the teams comfortable with moving forward with EIP 2537? If there are concerns about implementation or security of 2537 that will cause a significant amount of more testing time, we need to know so we don't have to have that EIP delaying Berlin. So as of right now, we kind of are moving towards what's in Yellow V3 going into Berlin. And what's in there also includes 2537. However, there were discussions over the past few months, I guess, or at least month and a half, about EVM 384 as being an alternative to 2537. My understanding of the discussion there is that EVM 384 is considered by some to be a safer alternative specifically for the use of the BLS 12384 precompiles. However, there is a few unknowns about it, such as how long it'll take entirely to build out. I know they've been giving updates and been working really quickly. The 384 team have, but there's the biggest question I think, and Alex Vlasov, correct me if I'm wrong, because I know you were the one who brought this point up. The unknown around how much it can be optimized gas-wise to be efficient for people to actually use on mainnet compared to 2537, which has been heavily optimized. And if there's even a person out there who could do the optimization work to get it up to par with 2537. So we're kind of juggling that right now, is the way I see it. Anyone can jump in if I'm speaking incorrectly on the topic, but we do need to figure out if we're having 2537 in, because I know that there's been some trepidation about putting it in for security reasons. So is there anyone who has comments or updates on the things I just discussed with this? And if not, I'll do more pointed directional talking points.
Well, if there would be no direct thoughts on this, I have actually an idea how to use EVM 384 and not have this work wasted.
Okay.
I mean, well, my concerns are largely 2 factors. One is performance, which is still unknown compared to, and also will compare as a reference performance, either my 1962, which is kind of slow, or an implementation which is in gas, which is actually faster. And if you take an assembly backend, it's even twice faster on top of this. So who will make a call, like if we accept twice performance, is it acceptable in general for users? But without numbers, we can only speculate here. The idea I have is the problem there is there is a boundary between the EVM and the internal implementation of the opcodes, and actually how you program them. And also, well, the current implementation of the BLS 12381 curve is kind of C macros plus assembly, at least for external user. And I don't know if many people would want to and be able to even review this implementation at the end of the day. I personally doubt that I could do it. So my idea is we can use the same work, so the same set of opcodes which is in there, namely additions, subtractions, and Montgomery multiplications. And instead of this, we can just re-implement, like migrate the precompile and have an approach to write the crypto precompiles using this set of opcodes. So it goes kind of backwards. So if mathematical implementation is correct, then the precompile implementation will be kind of as correct. And if there is some intermediate language to write it, so it will be also kind of one implementation across all the clients, but just the lowest level arithmetic implementation will be language, will be client specific and language specific. So we might it will save going back and forth through the boundary of the virtual machine, and simultaneously it can kind of get to the point when there is a single reference implementation between all the clients, and it's well, it will be single one, which people didn't like, but simultaneously there will be no consensus divergences in this case.
So are you talking basically about the system contract, which uses regular EVM opcodes? Is that kind of the case?
Well, it's kind of EVM without all the functions of EVM. So it will be very small, like it will be set of 3 or 4 exported functions, which you would be able to call, and those functions will be implemented by Ethereum client. But actually calling them will happen without any overhead of EVM itself, without care about the endianness of the encoding, with possibility to use the stack and not the memory in EVM, and similar benefits. So it's kind of, if you look at, this is actually kind of how 1962 is written. There are functions, namely addition, subtractions, and multiplications. And those are basic ones. And everything which implements a specific curve is on top of them. So we can continue kind of do the same approach, and EVM 384, they have like, they want to give these functions to the EVM level to users and final contracts. What I think it's possible is kind of hide it one level down, and that eventually it will be possible to just re-implement crypto precompiles using this set of 4 functions for field arithmetics, up to some modules. And right. then it's kind of possible to reach the point where performance is going to be like how 1962 is written, because it's also written in a way that it's not made for a specific curve. It allows to capture part of the optimizations in runtime, but you have inefficiencies everywhere because you cannot inline constants. You have to inflate sizes of the structures, keep some references. So it would essentially be the same. It can be very well merged and well served as a reference crypto engine, something like this.
But if that were to be a goal, then I think it would be a mistake to go with the precompiles in 2537 right now. Because if we add them forever, and they will always be in the code base.
No. I mean, we can add them, and that if we would want at some point to flip a switch, those can be re-implemented using the same primitives. And for example, 2539 for similar sibling BLS12 curve, it can be also re-implemented in a similar manner. So for external observers, they will be precompiled. So there will be fixed address, they will be an ABI. Internally, 2539, and internally, it would look like, it will be an implementation which calls some internal functions of the node, but those functions will also be standardized, and namely as the same opcodes of EVM 384.
So is that a more secure way of using the precompiled codes, or is that a more efficient way of using EVM?
Well, it's
versus trade-offs. I'm curious about.
Well, it's kind of proposal which does the following. It potentially reaches good performance numbers, potentially. At least I think that it would reach the same performance numbers as 1962 implementation. Well, it will not reach the optimum where you can hard code everything, an absolute best performance, but it still will be very fast compared to like the same price as precompiles are priced right now. And the drawback is that it's still going to be kind of one reference implementation in all the clients.
Yeah, but it somehow also captures a bit of the worst about both cases. I mean, with precompiles, everything can be optimized, and the drawback is that you have a lot of custom things that need to be implemented on the side of the EVM. You have more in the consensus critical part. If we were to go only with these small Lego blocks available to the EVM, we would have a lot less in the consensus layer of the nodes, and all the sensitive stuff and more advanced crypto would be built in layer 2. So we wouldn't need to be concerned about consensus flaws there, really.
Well, that's why it's only the idea, and at least for now, I mean, without any numbers for performance, and without even at least I don't have any idea how the final contract will look to, which actually implements PLS 12.381 at least curve operations in any language which was chosen by guys who do it.
I just saw that. Sorry.
Yeah. I mean, I cannot make any judgments about this, but at least the performance is crucial, especially because, as we had a discussion yesterday, actually it was a very good idea to remove additions and multiplications altogether and just leave the multi-exponentiation operation. But since we kind of optimize for very few kind of specific cases where we want a best in class performance, like we have to keep additions, and also we have to keep up with performance. So please continue, Martin.
No, I was just going to say that I saw that Axic is on call, and I was wondering if Alex Bergsasi has any thoughts about the discussion.
Axic, can you hear us? So is your mic working?
Yeah, sorry, I didn't realize the time zone change.
That's okay.
And I haven't listened on YouTube either, so I'm not fully sure if I understand the discussion correctly. I only joined probably 5 minutes ago.
Yes, we got to starting talking about 2537, and there was a bit of discussion during the week in our Cordev channel, where basically EVM 384 versus 2537 or both, or like what is a sane approach? Should we do both? Should we do one of them, and which one? And Blaso is talking about performance of the one versus the other. Yeah, so I was wondering a bit about, for example, the performance numbers, and also whether, because I've seen them as two approaches that are not like hand in hand. I mean, as I've seen it, it's one or the other, but I may be totally wrong about that. So please, do you have any thoughts?
Well, I mean, even depending on an amount of workforce required to finish EVMs 84 and maybe some set of tools, so external developers can easily implement new curves or maybe some other operations required. I would be glad to see both. So just in case if there is something needed, then you can get it immediately without waiting for example, another precompile and even going through this process. I mean, I always try to optimize for performance, so maybe it's just a personal opinion. So if there is already an implementation which is faster, I would want to have it.
In my mind, we shouldn't optimize for performance if it means we need to add new precompiles for every curve that we possibly want to support. If we can instead do the simple thing of just adding a few basic bricks, and yeah.
Well, the problem here is that when you say for every new curve, I mean, in practice, there will be not a large variety. There are curves with specific properties which you really want. And this set is very limited, like very, very limited. If
Alex,
ever in the future, yes?
Sorry, Alex, to interrupt. Would 384 even be sufficient for every new curve? Would it be enough for, say, BW6?
No, it wouldn't. Just because the field size is different. And I mean, I was mentioning once that, for example, it may happen that for 324-bit arithmetics, the cost of crossing the boundary of the EVM dominates the performance. So not arithmetics, but just everything else. Maybe for 768 bits, it will be the opposite. And then it's like, it's a clear win. It's not, there is no reason to make a precompile which would implement this, just because performance will be essentially the same. But for 384, well, what you could do, BLS 12 381, BLS 12 377, and potentially there are well, there are fancy curves for another forms of recursion and half-pairing cycles, which are BN curves over fields which are roughly 380 bits, and those you can also do. But other than this, there is not much variety of choices of which I am aware, which people would want to use kind of at this point in time. I cannot project into the future. Maybe someone finds something extraordinary. I don't think it will change the picture. So the set is limited. And well, again, performance numbers should be there first, so to make any judgments.
When you say crossing the EVM boundary, what do you mean by that?
Well, I just mean that, if just because you execute it as any other opcode in EVM, it means you do all the other stuff in EVM, which you have to do during this opcode processing, plus I don't know how much time does it take to re-encode big endian and little endian. So compare all of this to one single operation, let's say Montgomery multiplication. Or like, let's say 80% of Montgomery multiplication and account that additions and subtractions have their share indirectly.
So wanted to reflect to something else. You said that the the implementation of BLS12 using EVM384, it's just hard to achieve, and implementations for other curves. So just to give maybe a brief update on that, there is almost a completely working pairing implementation using EVM384, and that is done by Paul, and it's not just handwritten for that specific operation. It's rather a system to write these operations. So what we're doing is we have a code generator script, which is right now written in Python, which generates which has the building blocks for the pairing implemented, and it generates optimized code using the EVM384 opcodes. And what this allows is that, I mean, one of the reasons it was done this way, because we had these different versions of the EVM384, and this way it was easy to change how the arguments are encoded. But it also provides a much more readable, I guess, source code, because the end result, what you want is something highly optimized. I guess what I wanted to say is that this is almost finished, which hasn't been the case. I guess when this entire discussion started, it looked much worse, that it may take forever to have an implementation of any BLS12 operation over EVM384, because there's just a lack of people who understand this crypto and understand EVM and are willing to write this. Should we have found such people, I think that there would have been an implementation for a long while. But at least we started to do it ourselves, and it's almost finished. So I think we're in a much better position to have final numbers to compare against. And another response to what you said, that this is still limited to 384 bits, which is correct. But the same kind of instructions could be introduced for bigger bit widths to cover more curves. Ideally, it would be nice if this could be fully dynamic, so you could have a single opcode where you specify the bit width. I guess that could be possible if you would have that as an immediate argument, and you would still put some limitations on that. But that goes, I guess, more into the direction of the SIMD proposal in a way. So we haven't proposed that. We only proposed to address 384 bit. But the same way, you could introduce 3 more opcodes for 768 bits.
So one thing that I'm a bit concerned about, obviously performance, whether these can be written performant is a question, but given the expertise needed to write the crypto, and given the expertise needed to write the EVM, and that there's a very small set that can do that, how I'm worried about our ability to assess the safety of actually writing these low-level operations, crypto operations in EVM. Whereas when we write them in standard libraries, it is hard, but there are experts that are available to audit, and there are techniques available to do formal verification, both of which on some BLS libraries are being completed today. And I'm just worried that we're going to have very complex EVM bytecode with little ability to, and not to speak against the incredible efforts going on in your team, but I don't know if there's an additional 3 or 4 people that can then spend the time to evaluate the correctness. Thoughts on that?
Well,
so I would argue.
The last thing I looked at the implementation, I actually don't remember what it was, but I think it was a set of scripts which would just placing instructions for the implementation. So, I mean,
Alex,
you say that you. Yes?
Sorry to interrupt, but I think that was for Alex B. And the EVM.
Whoever could speak to it. Sorry.
Or whoever.
Well, okay. I mean, the only concern here would be, can we also, like, it should be good then to also check the code generator and optimizations used in this are sane and sound. It's also not my area of expertise. But yeah, it's a good point that someone brought, whether even if there is a tooling which other people would be able to use to, for example, to write some other curve operations using this set of tools. I mean, it is necessary to, otherwise no one would be able to actually get their hands in and implement some crypto. But then we need to also reason about the sanity of these tools themselves. And for performance numbers, the last numbers I seen was some comparison with the old version of 1962, which was then updated, and then as a reply, maybe from Paul, maybe not from him, it was that, well, the latest commit for 1962 is actually twice faster, and it's what's kind of reflected in new pricing for 2537. So the numbers are changing. There was a huge progress on EVM 384. It's just a question down to what this progress can go, and also down to what this progress can go in every particular client, because there was also a note that such implementation is like 1.5 times slower than in EVM1 for whatever reasons. So without those numbers, it's not possible to make not possible to reason about whether it's good to replace a precompile altogether with this or it's not. I would say performance matters, so it's not. But eventually, if this work is complete and everyone is satisfied that it's safe, then it can be also included as a tooling, at least for other people to write crypto in EVM, like maybe very well specialized crypto.
Okay, so Axic, what about you?
So I would like to give answer to Danny as well, but I will start with very briefly, maybe responding to this performance question. So back, I believe, probably in April, when all of this work started and discussion started, and the initial results were posted, Alex, you said that the speed of the precompile at that given time was already at the speed which makes it feasible for your use cases, and that is the speed we should target, and anything slower than that is unacceptable. And we actually are quite close to that speed, if not matching that speed. Now, since that time, I understand that the speed of the precompile may have increased. But that doesn't really stop from this old statement to be valid. You know, the performance requirement has been met. And now with the precompile speeding up, now with the precompile speeding up, since the precompile hasn't gone into the chain at that point, I guess we do have the ability to maybe use a faster version of the precompile to go into the chain. But if you assume that maybe it has gone into the chain in April, then would you have a chance to upgrade the precompile to be faster? I think upgrading precompiles is quite a lengthy process if you look at all these repricing discussions. And compared to that, you do have an ability to optimize code using EVM 384 opcodes. You don't need a hard fork to do that. So that's just a response to the speed. But Danny, to your question regarding complexity, based on your question, I get the feeling that people may think that this, I guess, crypto code using these EVM 384 opcodes looks complicated and is like magic. But I would argue that it actually isn't. The EVM 384 opcodes are basically just those same very building blocks which many of the BLS12 implementations actually use internally. And they have those building blocks, and they use that in the higher level operations. And EVM 384, I mean, any implementation using EVM 384 does the very same. So as long as you can, in terms of like verifying this, you basically have to, you can detach the opcodes, at least in terms of verifying the, let's say, a pairing operation, BLS12 pairing operation, in EVM, you don't need to provide a proof for the opcodes. You only need to provide a proof for whether those opcodes are used correctly. Now then separately, you do need a proof for the opcodes themselves. But if you want to verify a, let's say, an assembly implementation of the same, you have to provide a proof for the entire process in the same verification. So I would, and those building blocks are pretty much the same as they are when you write them in assembly or C or other languages.
Right. And understood. I would say the practical question on my end is, do we have, if we had these implementations completed, do we have someone or multiple parties that we think are capable of auditing them, or do we have someone who's capable of formally verifying them, you know, from a practical standpoint?
I would say we do. I mean, as one example, you have KEVM, if you only want to look at the EVM part. That being said, of course, KEVM doesn't support EVM 384 operations, so that would be extra work.
Right.
But I don't really think this is, you know, this is something which would take just verifying like a BLS12 pairing on EVM 384. I don't think that would take, you know, in order of like 2 years or 3 years or something like that. And I do think that the baseline tools are available. But yeah, I do agree that it's probably not as straightforward as, I don't know, verifying the Rust code, because not many people have done that.
So, I don't want to take the whole meeting on this topic. So the primary question I had in asking this is less about if 384 is a good idea. It's more like if it should completely replace 2537 because of people's concerns over security, and if there's, you know, if it's more efficient and things like that. Those kind of questions, those need to be discussed, because otherwise Berlin could be pushed out all the way till well into next year if we keep doing this. So we need to come to a decision of, are we going to be putting both in, or at least putting in 2537 and then deciding on 384 later, or are we scrapping 2537 because of problems that we deem too important to put into the chain right now if 384 is going to solve them? So that's kind of how I see it. And personally, I think we should have both of them in, because, I mean, I don't know, I'm not a client dev, so I don't know about like client bloat from having stuff like precompiles in the code that then are like not used after a certain amount of time. But looking at, I guess I think about it as, how long will these be usable until ETH2 type of logic can be used instead for more general purpose stuff, or is this going to be used, you know, a long time from now? Go ahead, Martin.
Doesn't matter how long they will be used, they will always be present. So if there is a vulnerability that can cause a consensus flaw in one of them, then it will be there. It will be sitting there for years.
Mm-hmm. So that would just be a safety concern then, right?
Yes.
Okay. So if that's the case, then thinking
But
about
does
it.
that,
Yeah,
sorry, maybe this is a dumb question, but that's independent of whether we do one or two of them, right? Like if we do, say, EVM 384 didn't exist, you know, there is a security risk about potentially having a consensus issue with 2537, and vice versa. Like if we didn't have 2537, you know, there's
Yeah.
still the risk there. So it's like, obviously there's like twice as much risk because we do two things, but there's no, like, they don't multiply in any way.
It just leaves it's just more attack surface, the more stuff.
Yeah, exactly. Because we'd add two things to the protocol rather than one.
Right.
Yeah, but I wouldn't count them as like one thing or two things. It's more like how much attack surface does the precompile make? Quite a lot. And how much attack surface does the individual opcodes make? And it's not like they're equal. I think
It's more like
the
moving
opcodes
this
are a lot
risk.
smaller.
Yeah, it's more like moving this risk from that we did
exactly.
a good job
Yes.
in implementing the precompile, or users
Right.
checked
We can move
the
this
implementation
risk from the platform into layer 2. That's what I like
and
about EVM.
simultaneously also responding to the argument about performance. Like it was
I can't believe performance. No.
Yeah, it was first of all, it was from the day one an invalid comparison. Like you would compare as the most general implementation for Curie arithmetic, up to some extent, of course, of 1962, which had some performance there, but since half a year later, it's now twice as good. And even before this point, all specific implementations, which are potentially used by the clients, and namely GAS, they are even faster than 1962 right now, at least 1.5 times. And my local computer if there is no assembly involved anywhere. So now it's a question. Well, we spent a year testing and optimizing and doing all this work to give users a tool which is as cheap as possible, or like as we comfortable to moving forward with the prices. So we leave ourselves at least 1.5 time margin in performance and its varieties compared to, let's say, gas implementation, at least. And well, there is a tooling for user. And Ethereum is a platform. So we try to serve, and especially very specific needs in this case. Or we say, well, guys, you have to pay 3 times the price, just because we were scared to even try to do it. And I wouldn't make this call for end users and wasting someone's money.
The other issue at play is that Open Ethereum is going to try to have an audit, or actually I'll have Open Ethereum speak to this because I just saw a comment in the agenda, but is there something like an audit that might happen depending on if we're going forward with this EIP, Jargon or Marcelo?
Yeah, this is Marcelo. We're concerned about this because the audit for EIP 2537 is quite expensive, so we want to make sure it's going to be included in Berlin fork.
Yeah, because right now we're more and more seemingly, it just feels on the fence about it. People do, so yeah, that's what I'm trying to get clarity on so we can move forward with stuff. So, Martin, when you keep bringing up the security concerns, it's hard for us as non-security professionals to gauge how drastic of an issue it is compared to other security concerns for any other EIP.
Yeah. So, I can't really put a number on it. It's obviously a lot bigger concern because us node implementers and client implementers who knows everything about how the EVM works and the semantics of this and that, we cannot meaningfully audit the code. We cannot meaningfully check that the test cases are, as you know, that they cover. It's a big unknown, and we can implement this and just hope that everything will work out. There might very well be consensus issues. That's not the end of the world. I don't know. What do people feel? I mean, I would feel a lot better with having smaller smaller surface on the platform layer and have people build the crypto in layer 2 as much as possible.
And 384 doesn't do that though, right? 384 is still layer 1 completely, I thought.
384 just enables people to build the complexities in the application layer, in the virtual machine.
Yeah, okay.
So we don't have to shove everything in the consensus layer.
Oh, when you say layer 2, you mean the virtual machine layer. You don't mean like...
Yes.
Okay, got it.
Yeah, not the normal.
Okay. Oh, go ahead.
So then if let's say we were to do it, is the amount of work to make sure it's safe, it just still feels like something like it's going to take longer than 2 or to 4 weeks to get this figured out.
To get which part figured out?
To do the work for the BLS precompiles to be...
Well, this might be a good time for my updates about that.
Sure.
So this is going to be pretty boring, as all good fuzzing updates ought to be. So, we have been running a fuzzer on EIP 2537 and 2539 for a while now. It was running on like 8 cores until recently, and we bumped it up to 32. So for this particular fuzzer, Alex wrote it. It's aware of the algebraic structures and generates valid and invalid inputs to fuzz the Rust EIP 1962 library against the Golang implementation that's currently in the draft Go Ethereum implementation of 2537. So one iteration is 2 executions of each precompile, once in Rust and once in Go. We've been running it for a little under a week on 32 cores and have done about like 270 million iterations with no issues or incompatibilities so far. And we did an additional 1 million rounds using the Go Ethereum RPC to get like the full end-to-end integration test. Like that's the whole update. Is we've been running this for about a week on 32 cores. We expect to keep running this for several more weeks.
Okay. So from hearing everything right now, where my mind is that, I guess I have a question for Alex Axic. So Axic, 384, what's the earliest it would be ready, in your opinion? Is there any way to know that right now?
Well, the opcodes are ready, but I guess the question is whether, let's say, a pairing operation fully ready implemented on 384. I mean, it's really hard to tell because right now it's mostly just us working on the implementation, but we do, especially recently, we do get input and feedback from others on this topic. But based on the progress of the past, I would say 4 weeks, because in the past 4 weeks, so like 2 weeks ago, we got the mirror loop done, and the last 2 weeks we got almost the entire final exponentiation done. So based on this progress, I really hope that we should have it done in by next all core devs. But
wait,
I cannot really promise.
But that wouldn't be that work wouldn't need any hard forks or anything to finish. You just deploy it, right? As long as the hard fork just needs to have the new opcodes.
Yes, that's correct. The having this implementation, the pairing implementation, the main reason it is being done is to have a fair comparison in terms of speed and cost.
Right.
Okay. Does anyone else have any major opinions on this, especially from a timing perspective that I've been trying to hone in on?
I had a question about, like, let's say if we move, let's say if we over the 2 weeks we have discussion and then decide that this one will be not in Berlin but in the next fork. How hard is that to remove from YOLO from like a practical perspective?
10 minutes.
Cool. Okay.
When's the earliest we estimate Berlin might happen, and the latest, just for reference?
Earliest is
2 to 3 months.
yeah, mid-January or something, right? Didn't we talk about that the other day?
Yeah, I think when we looked at the schedule, like if we rush things a ton, which I don't think we should, we could maybe get it out by like mid-December, but I think mid-January-ish is probably a better estimate. And this assumes, like it's kind of like if you don't think about BLS for a second and you just look at everything else and assume the process goes smoothly.
Yeah, so taking out BLS mid-January, or even keeping it in mid-January is a possibility.
Yeah, taking out the arguing about BLS, right? Like.
Yeah.
Oh yeah. How long it could take with arguing about BLS? That's the mind's the limit, Danny. It can be as long as we want Berlin to take, if we don't get forward on this.
Well, we can simply pick a number, which we say, well, if performance is within this from Go Ethereum's library on the same machine, then then this number is okay for everyone.
My issue is less with the performance, because even if we assume that both get to a performance that's acceptable, it's the timeline and interaction with the community. So if I'm thinking about 384, realistically, that's like a year for all of the before the hard fork and the optimizations and all of that stuff has happened. And so then there are scaling solutions, like layer 2 scaling solutions, ETH2, people that are essentially wanting to use the BLS curve and are unable to. And if we say, hey guys, like, are we comfortable telling them to wait a year so that we can be more comfortable with the pushing the security stuff? Or conversely, do we say, maybe this is the BLS stuff is too much to do in the next 2 weeks or so, so we instead have a fork for it early next year in like March or April. That means that they wait like 4 or 5 months versus a year, but we still get time. It's more of the timing stuff, I guess, is the like because we could have both and allow the community to use the features.
Yeah. And what used to kind of happen is, I think some of us I remember just kind of making decisions before, like older core dev meetings of just like, we're doing this, but I don't really feel comfortable doing that with the BLS thing, and I don't think that'd be fair anyway. So I think in absence of a decision, there will be no action, for that reason. So that might delay Berlin, and that might involve just going forward with Berlin without BLS and then figuring out the BLS issue later.
Yeah, I would tend towards the latter of the taking it out of Berlin and saying that it'll be in the next thing, but have the next thing be sooner.
Yeah, something like that could work out for sure. I feel kind of bad because I know it'd be useful for some verification stuff on ETH2, and that there were other, of course, all the stuff that James wants to do to, and his cello and stuff like that want to do with using this curve. But yeah,
I can speak to the ETH2 context. There's two main reasons that people want it. One would be to add additional verification to the deposit contract to prevent loss of funds in some cases. This is not requisite. Any tooling that you're using should protect you, and that has been a major push in the past few months. Additionally, beyond and also for Genesis deposits, we don't expect that this precompile would help. So it would be in subsequent deposits that it might help. So it's not going to have a tangible impact on many deposits that are going to happen over the next couple of months. The longer term thing that we're very interested in is ETH2 light client verification inside of ETH1, efficient light client verification, which would require a BLS precompile, at which point the ETH1 chain can learn about the data layer of ETH2 and rollups and things can leverage that scalable data layer before a merge. So that's the major one. That's easily 10 to 12 months out. But if we do get to that point in which we have scalable data layer on ETH1 and ETH2 and can't use it in ETH1, then it kind of sucks. So that's the major priority.
Here I can immediately disappoint you that for this particular purpose, as was discussed yesterday on in your Discord channel, there is some kind of fun with addition operations of the curve points, which requires inversion, which potentially may be prohibitively expensive if the inversion is implemented using the EVM opcodes. Well, not prohibitively, but you will get like 3 times amplification factors on top of the suboptimal performance before.
And that's specifically on BLS aggregation?
Yeah.
Right. I don't have a good handle on how that might affect, but this is probably like one transaction that some actor is sending with 128, maybe 256 aggregations and 1 signature verification per 6.5 minutes. So I don't know if that is cost prohibitive, but it'd definitely be worth.
Well, I mean, it's just a factor of like more than single digit, potentially more than single digit number. So it's what I call prohibitive. But it also depends who will be paying this cost. If you don't care, then why not?
Well, I mean, I definitely need to fit it into a single block. But right, then it could be prohibitively expensive.
Danny, for like, let's say that BLS stuff was March, April of next year. Does that work with the timelines of things you're talking about for the longer term?
Yeah, on the longer term stuff that we're interested in. Yes.
Yeah. So I don't feel comfortable making a decision between BLS and EVM 384, but I will push Berlin. I will push the BLS EIP out of Berlin because it's just taking too long. It's like it keeps holding back all the other stuff we're doing.
Okay. Yeah, I agree with that. Anybody else have opinions on that?
Yeah, I think that we should split Berlin into these separate paths, one for BLS and any EVM changes, pre-compile changes, second for 2929 plus 2930, and potentially 2718, and the third path for anything else that we already tried to add, because now with 3 to 5 months for Berlin, people will be pushing very hard for adding new things, and they'll start being...
Oh, Berlin, just to clarify my comment, I would say Berlin would come out in like the 2 to 3 months, maybe December/January. But if the BLS stuff would be after that.
Yeah, all he's saying, James is just saying release everything in YOLO v3 except the BLS curve stuff by mid-January was his implication. That makes
mine
sense.
is very similar.
Okay.
I'm trying to show that we should already show people the path for anything else that we can start to work on it in parallel. So people don't see that work as serialized and waiting for Berlin to happen if Berlin has some delays around 2929, for example. Because people will be pushing for addition of the new things. I like this 2666 is one example. Like we already mentioned it as potentially being added. So.
Okay, I got what you're saying. Okay. Well, what we'll do is, unless there's something major that happens between now and the next meeting, let's not have BLS like 2537 or obviously EVM 384 in the next Berlin hard fork, and we'll either do a thing where we split Berlin into two, like we've done before with other hard forks, or we will. By that time, we're going to hopefully by the time Berlin happens, we'll hopefully have had a plan in place and more organization around how to get EIPs through the process that's more clear for the public to come into a meeting and pitch their idea and their implementation and their EIP and be able to successfully do that without being roadblocked by other EIPs. Is that kind of what you're trying to accomplish, Thomas?
Yeah, sorry, just showing the people path for things outside of Berlin to happen in case Berlin is delayed, so they can start to see that maybe simpler changes may come before Berlin if Berlin is delayed. So to start showing some parallelization of the bundles of heaps.
Okay, that makes sense. Okay, so there's that decision's been made just for the note taker. Basically, unless otherwise indicated over the next 2 weeks before the next meeting, BLS or 2537 is out of YOLO. Or should we take it out of YOLO too to be clear, James?
No, it would be YOLO V3.
So take it out of YOLO V3 and delay it beyond whatever the next hard fork is going to happen.
Yeah, unless someone is feeling really strongly otherwise.
Sure. Okay, so there's that. We already had a fuzzing update from James. Thanks, James. So that's that off the agenda. So agenda item 2 is account abstraction discussion 2938 or EIP 2938. Sam, are you on the call?
I am, and so is the rest of the Quilt team.
Oh, excellent.
So I think where we left off at the last discussion is we were looking for feedback, figuring out what the process was going to be, and we were wondering what we need to do to get it to the considered for inclusion state. Is that right, Ansgar? Is that where we left off?
Yeah, I think that's basically it. I think it's not a big issue for now, just because obviously right now the Alcodev is mostly focused on Berlin, and this is definitely not part of that discussion. Or even if it's like Berlin will be split up or something, that'll definitely not land in any of those. But yeah, basically, I think last time actually, I think maybe it was Martin or something. Right, who said the GET team wanted to have a look. I'm not sure if you had time to do so yet. But also just in general, basically, what I'd just be interested, or we would just be interested to hear like what like remaining stepping stones there would be for an EIP like account abstraction to just be moved to consider for inclusion.
I am sorry, I personally have not reviewed it as much as I should have. Sorry about that.
Yeah, I mean, no worries, obviously. But then the question is just because we would like to make some progress here, does it just make sense to I mean, I assume obviously you're busy right now, like the GET team in general is probably rather busy right now. Is there like how much effort is there for you guys to determine? I'm not sure. Basically, like what I'm saying is basically like I'm not fully sure what the threshold here is to move to considered for inclusion. What exactly is the standard that an EIP has to meet? And how much effort is there to evaluate basically?
Mike, or Martin, go ahead.
You go ahead.
That the consider for inclusion doesn't mean that we understand or know what the EIP would need to be to actually be included. There's the small assumption that if a PR that was like sufficiently and correctly formatted would be accepted by the core devs. So it's actually, I think, lower than what you're going for at this moment.
Okay, then the question. So So does it still mean that like at least some very basic approval by the Get team is still necessary though? Like no, not obviously approval in the sense that we would want that to be included. More like that looks feasible or something. Yeah, I don't know. It's just a little bit hard to pick out exactly.
Yeah, I think you got it right there. It's not like if it's gonna be included for sure, but like if it's possible, would it be possible kind of a thing, and if it would be supported on a just a general level, yeah, the client teams would decide that. So that'd be like Geth, Open Ethereum, Nethermind, and Besu.
Okay, and then where would the best place be to follow up on that? Because I think ideally, basically, I would just want to maybe talk about it next Awkward then again to finally maybe move it to CFI. So where would I best follow up there?
To remind people to give feedback, I'd say the All Core Devs chat in the ETH R&D Discord. But Martin, what was your comment?
Yeah. No, I was going to say the same thing. Awkward Up Discord or some other Discord, or yeah, but that's probably the best.
And should we do a breakout room for this maybe, or is that not really
we don't need a whole breakout room yet for it, but what we could do, I mean, account abstraction already has its own channel in ETH R&D, right?
Yep.
Okay. It looks like, yeah, and it's actually pretty active. So what we can do is, if you want to, you can, in the ETH R&D Discord, you can tag people like, if you have questions for certain teams, you can tag whole teams by doing at and then the team name, so like at Geth or at TurboGeth or at Nethermind, etc. And that'll ping people from there. And then if you don't get responses from some of the teams, or if you're interested in talking to certain people, talk to me or James Hancock, and we'll connect you with the people you can talk to.
Yeah, and I think for the breakout room, if you can post the EAP and Alcor Devs and we can review it there, it feels like we'll have a better understanding of what might be the specific things we want to discuss maybe on a call once everybody's read it and people kind of have a better understanding of it.
Sounds good. Although I would say like maybe like main discussion of the AP is probably better placed at a point of time after like the main Berlin effort is done, because I think there would definitely be like need to be quite a bit of discussion on whether this is actually makes sense on mainnet or not. But I do think right now it's probably it's a bit too early in the process. Yeah. But okay, then we'll follow up over the next 2 weeks basically, and then hopefully we'll be in a position to decide on CFI in 2 weeks.
Yeah, that sounds great. Yeah, sorry if that was a little confusing, but yeah, if you have any other questions offline, feel free to reach out to me as well, or James Hancock, or we'll help out.
Yeah, but anything between like you have clients with specific questions with specific clients, or just the process in general, reach out to me and I'll help make sure that those lines get crossed.
Awesome. Yeah, no worries. Thanks for the help then.
Awesome. Okay. Before we go, James, can you pull up the calendar link to the All Core Dev and like Ethereum PM calendar to post in chat, and then the All Core Devs chat in Discord? That'll be helpful for the time zone changes that have come up and are coming up for certain places around the world. There is a calendar that James created that has stuff like the ETH2 call, the 1559 calls, the All Core Dev calls, that kind of stuff, and it adjusts with time zone. So if people want to add that calendar to their calendar software, there's a link that will be posted in this chat and in the All Core Devs chat in Discord, or in the ETH R&D Discord. So that'll be helpful for people with the time difference. The last item, we only have a few minutes left, but this will be a quick one. There's been issues on Ropsten. Does anyone have an overview of those issues? I don't think there's anything we can do because it's out of our control, as far as I know. But does anyone have an update on the issues, and if there's anything to glean from that? I think the block gas limit was lowered, right?
I just want to know if there's if it's something that's going to work itself out, or if it's something that needs to be something done about.
I don't think we can do anything, but who was talking before? Micah, maybe?
Yeah, the very short summary is that basically very few people mine on Ropsten, and so if someone gets it under their skin that they decide they want to take over Ropsten, it's relatively easy. And when they do, it's kind of random what damage they do. Sometimes they just simply don't mine any transactions, like they just disable transactions or something, and so they just mine empty blocks for hours or days on end. Or they will lower the gas limit, or they'll raise the gas limit, or they will just basically be a pain on Ropsten. And the only thing we can really do is just get people to mine Ropsten, which means get people to throw 1E8 down the drain. So not a lot.
Can we create a permissioned ETH chain where we have ETH so we can still verify the behavior of testnet in the case of using various block times and random block producers, but at the same time limit the list of block producers to addresses that we have control over?
Another thing is like maybe client teams can just run a miner. I don't know what the hash rate is on Ropsten though. Like, is it?
It depends on whether it's under attack or not.
Yeah.
When the attacker shows up, it skyrockets, and then when they disappear, there's nothing. It takes like hours before the difficulty drops low enough that anyone can mine a block.
Because that's the thing. I don't think, like, for example, for us at Basic, we wouldn't mind setting up like one GPU or whatever to mine on it, but obviously, it's cost prohibitive to like set up a large amount of hash rate on the network.
Yeah, I remember. I think the EF set up a really beefy instance to mine Ropsten, and we've like left it on accidentally, and we're like just like majority miner of the network for a long time accidentally. That was a funny story. So yeah. Does anyone? I mean, I guess is there anyone like really begging us to get Ropsten back on track, or aren't most people using a POA network like Gorley or Rinkeby?
I've had a couple of people reach out to me.
Yeah, I've had some people reaching out and asking what's happening because I think the gas limit on blocks was something like 600,000, which means you cannot deploy any contract.
39,000. Wow, which is like 2 transactions.
Maybe that not enough time to figure it out. But we just tell people it'll work itself out eventually.
I mean, yeah.
I don't think that's actually true.
Yeah, it might not work itself out. It could just stay under attack.
Oh man.
I think Thomas's solution, I think, would solve the issue if we're willing to do that. Like, it would give us a proof of work testnet that is not constantly under attack. Otherwise, I think we have to just hope that the attacker gets bored, though they've been doing this for I don't know how many months. So I don't know if they're going to get bored. Like, this might just be such a small drop in the bucket for the attacker that they don't care. They run it.
Yeah, we can create a very small change for the clients where if Ropsten chain, then reject any blocks that are not from the list of addresses. Like super simple change, I think, for all the client devs. Do I seem right? Martin, what do you think? Other guys?
Yeah, well, you also have fast thinking. If you run into problems, you try to verify. I don't know, write an ETH. I guess I think that's their. I mean, it's a new consensus engine basically.
Okay, if someone wants to spearhead that, let's talk about it on the All Core Dev chat in Discord, or put it on the agenda for the next call since we've run out of time. And I don't think anything would happen in the next 2 weeks anyway, unless we spin up some miners. So yeah, if someone wants to do that or take the initiative and invite others to do it, just talk on the chat or talk to me and I'll spread the word. I'd be happy to do that. All right, do we have anything else before we go?
Hassan, I placed 2666 to the comments to this meeting, but I don't know if you placed this to the agenda.
2666.
Yeah, update the prices
Oh,
of pre-compiled.
sorry, I missed that comment completely.
Okay.
Yeah, to propose it for on track for discussion. I see. Okay. Yeah, do you want to talk about that for a minute? We're already over time.
Well, I mean, all the clients, developers have sent me their benchmarks, or I did it myself for gas and open Ethereum. So the final numbers which I derived in this proposal are what's right now the state of the art. For all the clients, at least it was at the point in time when it was the last updated. So it should not include, so it should not add any DOS attacks, but will streamline prices of doing these operations into what these operations actually do under the hood and what is the current performance. So in the essence, it's simple constants change.
Got it. Okay. Any comments on that, anybody? Okay, yeah, let's make that one of the first agenda items next time, if that's okay, Alex, and we can go more in depth.
Well,
then.
I mean, we can, if there are no huge objections, we can just put it into the YOLO V3, and then we can get it into the Berlin. But just like as the same way as people wanted to put ModX, which is also simple constant changes, in a YOLO V3, I don't see why we should not do this the same.
There's other considerations I'm guessing we haven't looked into, but is it really as simple as just like all the benchmarks are in? Is there anything else that needs to happen?
I mean, client developers already did everything for me, so I was able to derive the final numbers for formulas from their performance numbers.
I don't think we should slip anything new into YOLO V3 when like 3 minutes overdue on the call time.
Yeah, I'd agree with that. I think that set a bad precedent.
I mean, we can discuss it next time, but not this time.
Yeah. Yep, that sounds good. Okay, so yeah, let's bring this up next time. First thing, sound good?
Yeah, well, it's a simple constant change, so even if we discuss it next time, we can still put it into the Berlin without much trouble.
If we want to, yeah, we'll see. Okay. Anybody else have anything? Okay. Time zone change. Everybody be aware of that for the call in 2 weeks. The next call is going to be at 1400 UTC on November 13th, 2020. Thanks everyone for coming. Bye.
Cheers. Bye-bye.
Thank you, bye.
Thank you, bye.
Bye.